Hey guys, today we're going to learn how to find the volume of rectangular prisms. Now you did work with this in elementary school, so I have a feeling that part of it will be review, and then the other part is what we're going to change up for 6th grade. We're going to start out with the definition of volume, and you need to understand that volume is the number of cubic units needed to fill, that's the key there, an object. We've been working a lot with area and surface area. Remember, those are where you find how to cover an object or to how to build an object. Here we're talking about filling it, okay? And since we're talking about cubic units, that's like taking little cubes and putting it into the object and counting the cubes. So when we are done, our units must have an exponent of 3 for cubic. So if you have graph paper, you will just have the word units with the exponent of 3 behind it, not a 2 like area. And like inches cubed, centimeters cubed, meters cubed. The exponent goes after your units, not after the number. And no matter what figure you're finding the volume of, the answer will always have cubic units, no matter what the shape. In 6th grade, we only do rectangular prisms. In 7th grade, you'll do cylinders, pyramids, cones, and spheres. Okay? And maybe it's 8th grade, I'm not sure. Well, elementary school, they taught you the formula of volume equals the length times the width times the height. In middle school and high school, we also use the formula of capital B times H. The capital B, that tells you to find the area of the base. And when we say the base, the area of the base of your rectangular prism. So that means it's the area of a rectangle. That's how you get LW. The area of a rectangle, which is your base, you would do length times width, and then you would multiply that by the height. That is why I don't like showing people to use the formula base times height for area of a rectangle, because then you would have to do base times height of the base of the rectangular prism times the height of the prism. Okay? One other thing I want to point out is if you find the area of a parallelogram, we do use BH, but notice that this B is lowercase, so that lets you know the lowercase is a dimension of your figure. Here, it tells us to find the area of the base. So we're going to just keep going with what you're used to. We're going to use length times width times height. So when you are asked to find the volume, first you look at your figure, say, okay, that is a rectangular prism. I'm going to write my formula, length times the width times the height. I want you to go and label the dimensions accordingly on your rectangular prism. Length is always across the front. Width goes back. Height is how tall it is. Substitute for your variables, 80. Remember, side-by-side variables telling you to multiply with height. Thank goodness we're letting you use calculators because this number is big. Once you type that in, you get 57,600, and my label is cubed. So it would take 57,600 little cubes that are 1 inch by 1 inch by 1 inch to fill this figure. And remember, it's not drawn to scale, but that's a lot of cubes. All right, so that's practicing with whole numbers. Here we have a decimal. Still, it's the same formula. Volume equals length times the width times the height. Label your dimensions. Length goes across, width goes front to back, and height is how tall it is. Substitute 7.8 times 5.4 times 18.4. Type all of that into your calculator, and you should get 775 and 8 thousandths cubic inches. All right. I think you could do this one without me, but I'm going to go ahead and work it with you. We have a cube. We could use the rectangular prism formula of V equals length times width times height. You could also use S cubed, where S is the side length, but you're going to have to end up writing out 3 of the dimensions anyway, so that's why I stick with length times width times height. So the width is 3/5, the length is 3/5, the height is also 3/5. These are actually nice. Don't try to use your calculator. If you have a calculator that has the fraction button, definitely don't use it, because on the milestones you're not allowed to use those type of calculators. When you're multiplying a fraction that is the same fraction times itself, you will not be able to cross-cancel to simplify. And that's unless your fraction's not simplified, you may be able to then. Good news. If that is the case, you don't have to simplify your answer. It's already simplified. So 3 times 3 is 9, and 9 times 3 is 27. 5 times 5 is 25, and 25 times 5 is 125. And these are meters cubed. All right. So this one is a little bit different because it has mixed numbers. Let's go ahead and come over here. Length times width times height. Length goes across, width is front to back, height is up and down. Substitute for your variables. So do you see how the process is the same? You write your formula, you substitute for your variables, and then you work it out. No matter what you're doing in geometry, whether it's surface area, volume, perimeter, you write your formula, you substitute and work it out. And 1/3. Now you've got to think back to at the beginning of school where we reviewed how to multiply mixed numbers. You have to make them improper fractions first. So you multiply the denominator, the whole number, so that's 15, add the numerator, 16/3. This is a fraction, so you leave it alone. Multiply denominator and whole number, add the numerator, and you get 4/3. Now let's see if we can do any canceling. Those don't. Those don't. Nope. Nope. And the first, the last don't. So we can't. You just multiply like normal. 16 times 2 is 32. And 32 times 4 is going to give us 128. 3 times 3 is 9, and 9 times 3 is 27. Okay, now if this were just a plain old math problem right here, you could stop and leave it improper. But since it's a geometry problem, or even if it were a word problem, this answer would not make sense to anybody. If I said, oh, the volume is 128/27 cubic centimeters, nobody's going to have a clue about how much that is. So we need to make it into a mixed number. What you can do to help you with yes, we could type in 128 divided by 27, but look what happens. Yikes. We can't write that. So we're going to make a mixed number and not a decimal. Good news. This will help us when we actually start to do our division. So if I'm going to divide 28 into 1, oh, it's 27. I have fixed that. Hold on. 27 into 128. This tells us how many whole times it's going to go. If you look, it's going to go 4 whole times. And then you just do your division like normal. That's 28, 8, 9, 10. Subtract, and we've got 20 left. Now we can write a mixed number. Here's your whole number. Go around like a clock. Whole number, numerator, denominator. And it can't simplify, so there is our answer. 4 and 20 over 27 centimeters cubed. Make sure you make it a mixed number because it doesn't make sense otherwise. Okay? Now if I said, oh, okay, the volume is 4 and 20 over 27 cubic centimeters, that gives people an idea, oh, it's almost 5. Okay? That's why it makes sense to do that. All right, I want you to pause the video and give this one a try. Come back when you're done. All right, welcome back. So check your work. Hopefully you got 3 over 32 cubic centimeters. If you did not, then you need to pause the video and see where you messed up, okay? All right, this is where things get a little more complicated. You have to read carefully, and it's going to tell you that the volume of the rectangular prism is 400 cubic inches. So that's very different. Before, we've been looking for the volume each time. Well, now they gave it to us. If the length is 10 inches and the width is 8 inches, we're finding the height. Very different. Again, you still use your formula. Volume equals length times width times height. Substitute for what you know. Normally, we bring down the V because that's what we're looking for, but that is not the case here. They told you your V. Under V, you put 400. The length is 10. The width is 8. And we don't know the height. There's your variable. So now we have a one-step equation. But before we go and try to do the inverse operation, we have some math we can actually do over here. Bring down your 400. Can't do anything with that. 10 times 8 is... That's right, 80, and you keep your H. Now, we need to get rid of the 80. Inverse operation of multiplying is to divide. Keep it balanced and do the same thing on both sides of your equation. So now we have H equals 400 divided by 80 is 5. Now guys, don't put cubic inches. A height, as you see on all of the ones that we've done before, are just a dimension, so it's a plain old unit, not a cubic unit. It's not the volume, so it's 5 inches. I think those are fun. So I want you to give this one a try. Come back after you pause the video. Check your work for this one. Again, if you have a mistake, pause the video and look at the work and see where you messed up. Okay, last one, and this is a fun problem. The rectangular prism below is made up of 48 cubes. So that sounds important. Each cube has an edge length of 1/2 centimeters. What is the volume? Okay, the most common mistake is to say, oh, well, they gave us the volume, and there's a half, so we're going to divide it because it's got to get smaller, and the answer is 24. No, 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 don't do that. Okay, so that's the first thing we're going to write down. Don't divide the volume, or multiply, I'm sorry. Don't multiply the volume by 1/2. Don't do that. That will not get you the right answer. Okay? Because if what it's telling you is each edge length is a half. So from here to here is a half. From here to here is another half. Now we could go all the way across and count that, but you don't want to do that. We have 1, 2, 3, 4, 5, 6 cubes going across. And if each one of them is a half, you just do 6 times 1/2, and you can do that mentally. It's 3. Same thing here for the width. We have 2 times a half, which is 1, and the height is 4 times a half, which is 2. Now find the volume. Volume equals length times width times height. 3 times 1 times 2. Oh, that's tough. 6, and we're talking centimeters, so there's your answer. This is not the only way to do it, but that is one method. So I'm going to show you another method. And you may like it. If you do, use it. If not, this one will work. So what we did was we multiplied each dimension by a half. Okay, we know that works. Well, now here's another method. Or it's very similar to what I said not to do. This tells us that each cube has an edge length of 1/2. So imagine we have a cube and, oops, sorry, this is a half, this is a half, and this is a half. If we already have a volume, which is 48, which is 6 times 2 times 4, we can take that and multiply it by the volume of one of them. Okay, so first thing you're going to do is find the volume of one cube. Length times width times height. Half times a half times a half is 2 times 2 is 4, 4 times 2 is 8. So that is the volume of one cube. Okay? And it's really cubic centimeters. But that's not our final answer because we don't have just one cube in this picture. We have 48 cubes. So you're going to do the second thing you're going to do is you're going to multiply the volume of the prism by the volume of one cube. Okay, well, the volume of the prism is 48. The volume of one cube is, oh, let me scoot that over. The volume of the whole prism is 48. The volume of one cube is 1/8. So make that a fraction, and then look what happens. Holy cow! You see how we get the same answer? Let me put that below because that's all squished up. I don't like squishy math. So that would be, the volume is 6 cubic centimeters. Get the same answer both ways. You just have to find which one makes sense to you. Okay? Well, I hope I've taught you some new stuff about volume and reviewed the things that you learned in elementary school. Good luck.